Hi, it's Miss Parrott, and as promised, here's some more chi-squared practice. Before we begin, I want to draw your attention on the AP Biology equations and formula sheet to the location of the chi-square formula. Here are the variables defined, including degrees of freedom, and then here's the chi-square table. Let's imagine that we had a choice chamber experiment where we put 80 pill bugs in the center of a 4-chambered choice chamber with 4 different environments of combinations of damp, dry, dark, and light environments. Let's go through the steps that we mentioned in the last video to help us solve this problem. So first, we're going to define our null hypothesis. The null hypothesis would state that pill bugs don't actually have a preference of environment, right? There is no difference. And the experimental hypothesis would be the opposite of that pill bugs do have an environmental preference. Step 2, let's calculate our expected values. Now, we're using our null hypothesis to help us determine our expected values. So if they have no preference, we would expect there to be an equal number of pill bugs in each chamber after a time of taxis, or like 15-ish minutes. So 80 divided by 4 possible environments is 20 pill bugs per chamber. Down here, though, we can see this is the data table from after we gave them 15 minutes. So we expected 20 in each, but we observed numbers that are different. The question is, are these differences statistically significant or not? We'll keep those numbers handy as we move into calculating using the chi-square formula. So if we recall, chi-square is a value we're finding using the formula the sum of the observed minus the expected squared divided by the expected. So we're going to do that for each of the 4 environments. All right, our observed in the damp and dark was 52 minus our expected, which is 20, squared over 20, the expected. Damp and light, we had 14. We expected 20, squared over 20. Dry and dark, we had 10 at the end. We expected 20, squared over 20. And then dry and light, we had 4 minus 20 squared over 20. So be sure, as always, when you are doing calculations that you're using the calculator you plan to use on the AP exam. The more practice you have with that, the better. So we'll start 52 minus 20 equals 32 squared. Now remember, if you're using a 4-function calculator, you're not going to have a squared button. You would just do 32 times 32 is 1,024. But we don't stop there. We have to divide by 20. And that's going to be 51.2. So 51.2. All right, 14 minus 20 is negative 6. Squared is 36. 36 divided by 20 equals 1.8. 10 minus 20 is negative 10. Squared is 100. Divided by 20 is 5. 4 minus 20 is negative 16. Squared. Negative 256. Don't forget to divide by 20. Equals, that should be positive, because if we squared, let's do it again. Negative 16 squared equals, interesting. I know. So see, this is why you got to practice with your calculator. Negative 16 squared. 256, right? One of the reasons we square is to make our value positive. All your values should be positive. If they're not, you need to go back and recalculate. Divide by 20. There we go, 12.8. So we're going to add these all up. That's what the sigma means, is to add them all up. 51.2 plus 1.8 plus 5 plus 12.8. So 12.8, well, let's just do it. 51.2 plus 1.8 plus 5 plus 12.8 equals 70.8. That's pretty big. All right, so that's our chi-square value. We're going to hold on to that for a little bit because now we have to compare that to our critical value. So to find our critical value, we need the degrees of freedom, n. That's our number of groups. So we have 4 environments. So it's going to be 4 minus 1 is 3 degrees of freedom. And then if we use this data table, assuming that P is 0.05, then we're going to find our degrees of freedom is 3, 0.05. So our critical value is 7.81. All right. So now it's time to interpret. Our chi-square value was 70.8, and our critical value was 7.81. 70.8 is much greater than 7.81. So if our chi-square value is greater than the critical value, we are going to reject the null hypothesis. This lets us know that the differences are not due to chance, they are significant. And that evidence is suggesting that yes, there is a preference, a strong preference. And if we look at our data, we could say that evidence suggests that pillbugs prefer damp and dark environments because that is over half the population went there. And that's an example of a time when we are going to reject the null hypothesis. Keep practicing.